Good morning, students. Our next chapter is the magnetic effect of current. As we studied in the previous chapter, that when a current is passing through a wire, then it produces heating effect. Okay. Similarly, there is also another effect known as magnetic effect of the current. Means when a current is flowing through a wire, then it produces a magnetic field around the wire. Okay, so the production of magnetic field around a wire through which a current is passed is known as magnetic effect of current. Okay, so let us discuss something about the discovery of the magnetic effect of current. Students, it is very interesting to study the magnetic effect of current because the magnetic effect of current are observed accidentally. Okay, there is no basic theories, or no one is care about the this effects of a current. But in 1820, when H.C. Oersted, it is a well-known or very famous physics. When H.C. Oersted working on their lab, working in their lab on electricity, okay, then Oersted observed that a needle, or we can say the needle of magnetic compass placed on the table or demonstration table, is deflected from its position when a current is passing through the circuit. Okay, so for this, let us draw a simple circuit to understand this. That battery is connected with some emitter, and then a switch which is open or maybe closed, connected with the resistance, and then to the battery. Okay, suppose there is some devices on which Oersted works on the table, and accidentally a magnetic compass is placed near the circuit on this demonstration table. Okay, when Oersted switch on the supply, then electric current is passed through the devices. But he realized that when current is flowing through the wire, this needle of compass deflected from its position to some other direction like this. Okay, Oersted demonstrated this phenomena a large number of times, and he concluded that this deflection is due to the flow of current through this wire. So he concluded that due to the flow of current, there is production of magnetic field around this wire, which force the deflection of the needle. Okay, so in this way, Oersted discovered the magnetic effect of current. So these effects are of very useful applications in our daily life, which can be discussed in detail. So before discussing further on the magnetic effect, let us discuss some terms related with the magnets and its property. So it is very well known that what is a magnet. Okay, all the students studying in the lower classes that a magnet is a substance which can attract or repel the other magnetic substances from without touching or from a distance. Okay, all the students also aware that there are different types of magnets, and the shapes which we already seen, these are of a bar type magnet, some other type that is a U-shaped magnet also, another one is a disc type, or a ring type, needle type. Okay, all these shapes can be easily available in our markets, and all the students are aware about the shapes of the magnet. Okay, and but the most important shapes are, first one is this one. This is the bar type magnet, and the second is this U shaped, or it also known as horseshoe because it is in the shape of horseshoe. So it is also called horseshoe magnet. Okay, we also know that a magnet has two poles. Here we write N and S, means it is a north pole, and S means it is a south pole. Okay, similarly in case of U-shaped magnet, one is north pole and another one is south pole. Okay, also we know that when we have a magnet like a bar magnet, and if we place some iron needles like this or some different pieces of iron like this, okay, so near this magnet, then these iron nails or these iron pieces is attracted towards the magnet. Okay, so we can say a magnet is a material which can attract the iron pieces, but not only the iron pieces, there are certain other materials like nickel, cobalt, etc., which can be attracted by the magnet. Okay, similarly there are some other materials which can be attracted or repels by the magnet. All these materials are called magnetic materials. Okay, now if we consider the two magnets, let us consider first one is this bar magnet having north pole and south poles. We already observed this phenomena in our childhood that if we place another magnet having the same pole near it, then both magnet experience a force, and this force is repulsive force. So both the magnet experience a backward force. Okay, similarly if we place the magnet in another way, that is, say south pole is here and another magnet also has the south pole. Okay, again they experience a repulsive force like this. Okay, so it is force. Okay, but if you place this magnet with their opposite faces facing, that is, first magnet having their south pole and then it faces the north pole of the other magnet. Okay, then we see that the magnet attract each other, and hence the force is inward, or we can say the force is attractive. So from this observation we conclude that when there are two like pole of the magnets are placed to each other, placed nearby, they feels they feels repulsion, and when the two poles of the magnet are placed nearby, they feels attraction. So we can conclude that like poles, like poles means the similar pole, that is north north south south, like poles appears to repel each other. Okay, and like pole, like and similar, like pole means, sorry, unlike means opposite pole, that is south and north. Unlike poles attract each other. Okay, so this is the property of these magnet or magnetic materials. The next one is magnetic field. Okay, what is a magnetic field? Field means the space which is magnetic. It means a field is the region or space around a magnet in which its force of attraction or repulsion can be experienced by the any other magnetic material. So we can write here magnetic field is the space around a magnet in which its effect means magnetic effects can be experienced. Okay, suppose we have a magnet like this, then the space around this magnet up to which its force of attraction or repulsion can be experienced, so this field or this space is called the magnetic field of the magnet. Okay, so that's all about the introduction. In the next video we will discuss about the field lines and their properties. So that's all about this. Thank you very much.